Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have t square divided by 3 is equals to 3 divided by t square, and we solve this problem for all the values of t. So here first we need to cross multiply the terms, and when we cross multiply the terms it will be written as t square is multiplied by t square is equals to 3 multiplied by 3. So here further you see that the bases on both of these two terms are same, so that we will add its exponents, and when we add its exponents it will be written as this is t to the power of 2 plus 2 becomes 4 is equals to this is 3 multiplied by 3 is written as 3 square. And now further in the next step here we need to rewrite this equation as in this form, and this will be written as this is t to the power of 4, and we move this 3 square into the left hand side and it will becomes minus 3 square, and this whole equation is equals to 0. And now further in the next step we need more simplifications here, and we rewrite this equation as this is t to the power of 4, and we write it as t square and its whole square minus this is 3 square, and this whole equation is equals to 0. And further in the next step here we need more simplifications, and here we use the nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b. So according to this formula, you see here the base of this term is our a and the base of this term is our b. So we just substitute the values of a and b into the right hand side of this formula. So after putting the values of a and b here, it will be written as in this form. Here our first factor is a minus b. The value of a is t square minus the value of b is 3 only, into the second factor is a plus b. The value of a is t square plus the value of b is 3, and this whole equation is equals to 0. So further in the next step we divide this equation into the two cases. The first case is we write t square minus 3 is equals to 0, and the second case is we write t square plus 3 is equals to 0. So from here we move this minus 3 to the right hand side and it will be written as plus 3, and from here we move plus 3 to the right hand side and it will becomes here minus 3. So further we need to solve these two equations and we easily get the values of t. So first we focus on here, and here we need to remove this square sign. So in order to remove this square sign we will apply square root on both of the sides. So when we apply square root on both of the sides, you see here this 2 and this square root are cancelled out by each other, and in the left hand side we get t, and in the right hand side we get a square root of 3 only. Further you see here when we apply square root on both of the sides, we will be write here plus minus sign on any one of the sides, so we write it on the right hand side. So these are the two real root of the given equation which we get here in the first case. So now here in order to find the other roots we need to solve this quadratic, we need to solve this equation. So here again you see that we need to remove this square sign from here. So in order to remove the square sign we again apply a square root on both of the sides. So again you see here this 2 and this square root are cancelled out by each other, and we will get here t is equals to, and here you see that we apply the square root sign separately on both of these two values, and we apply here on square root of 3, and we apply the square root sign on minus 1. And further again you see here in this case we again apply square root sign on both of the sides, so that we again apply here plus minus sign into the right hand side. And now again you see here the negative sign appears inside the square root sign, and we know about that this will be equals to a imaginary number. So minus 1 square root becomes imaginary number, and imaginary number is iota. So these are the other two complex roots of the given equation which we get here in the second case, and these are the two real roots of the given equation. So finally we have there are four roots of the given equation, and all these four roots are becomes a solution set in which the two roots are real roots, and these are plus minus square root of 3, and these two roots are complex roots, and these are plus minus square root of 3 into iota. So this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.